Next section is annuity. First actual notation for annuity is A per XY. It defines APV or actual present value of an annuity of RM1 Malaysia per year, payable continuously as long as the JLS survive. So, as long as the JLS survive, the lower bound from 0 and the upper bound is infinity. The difference between annuity and insurance, annuity only pays for the survivors, 1 and 2, but the second component, instead of TPXY mu XY T, it's only TPXY. So that's the difference between annuity and insurance. So for the JLS, like the insurance, TPXY is TPX times TPY. Second one, actual present value of annuity of RM1 Malaysia per year, payable continuously as long as the LSS survive. So this is for LSS. We have XY with the bar, and the bound also same 0 to infinity, and we have VT times TPXY with the bar. So the difference from the first one is just the TPXY. From here, when we take out one by one, we get, this is annuity for X, this is annuity for Y, and this is annuity for XY. Alternatively, we also can rearrange the equation like this. Number 3, we have term annuity or temporary annuity. So APV of an annuity of RM1 Malaysia per year, payable continuously as long as the JLS survive within the next N years. So we have term here. So the bound from 0 to N, and as well as for LSS, must survive until N years. So for LSS is the TPX plus TPY minus TPXY, same as the whole life annuity. We can expand this equation and we can rewrite it in the notation. It becomes, this is for single life annuity, and this is for JLS annuity. Example 6. An annuity to X and Y pays RM1 per year, payable continuously while both are alive, and 2/3 per year, payable continuously while one is alive. This is for JLS. So the NSP or the APV equal to 0 to infinity, because whole life, VT TP XY dt for JLS plus 2/3, which one is, while one is alive. So 0 to infinity VT/TPX. So this first, if one is still alive and Y has died, or it also can be where while Y is still alive and X has died. We write down in terms of notation, it become example 7. A continuous annuity to 40 and 50 pays RM1 Malaysia per year while both are alive. Same as example 6. The first one is for GLS and half ringgit per year after the first death. So this is for LSS. APV or the NSP 0 to infinity. So this is Y, X, and this is Y. We convert into notation. Recall relationship between insurance and annuity. So AX annuity is equal to 1 minus AX over delta. So we can find annuity at 40 using insurance. For De Moivre's law, the upper bound is omega minus X. The VT is E negative delta T. And the PDF is 1 over omega minus X. Then we can find the annuity. One minus A40 over delta, and the answer is 8.337. And now we find annuity for Y using insurance. So APV for example 7 is equal to 8.175. Last section for chapter 1, contingent probability. First, we look at probability for JLS. NQXY represent probability that the JLS will fail within the next n years. If we draw the timeline, X to n years, to get the probability of death, we have to integrate PDF, which is TPXY mu XY T, from 0 to n. There are two possibilities, either X dies first or Y dies first. Look at the first possibility. If X dies first and within the next n years, we put 1 on the X. We integrate TPX mu X plus T and times TPY. So meaning that we are looking for the probability that X dies first while Y still survive. At T. Second one, probability that X dies second and within the next n years. So we put 2 on the X, same as the first possibility. However, we assume that Y is already die at time T. So we expand this equation become this is NQX and this is NQXY1. Next one, probability that X die first in year n plus 1. If we draw the timeline, x, x plus n, x plus n plus 1. So we are looking for the probability that x dies in year n plus 1. So the bound would be n to n plus 1. And we integrate Tpx mu x plus t, since x is die first, and Tpy, since y survive at t. Actually, the probability that x die first plus the probability that x die second within the n years is equal to nqx. And the probability that x die first within n years is not equal to the probability that y dies second within the n years. Example 8. Compute the probability that x dies second in n plus 1 years. So here is in the third year. So if you draw the timeline, dies second within this year, the third year. So this means that x or 20 dies at time t. And this one meaning that y has died at time t. So recall De Moivre's law. Ft or the PDF is equal to x, and TQX is equal to T over omega minus x. So this is TQ 30. So the answer is 0.0021. Example 9. So this time you have to use constant force. So recall for constant force, the PDF is mu E negative mu T, and the TQX is 1 minus E negative mu T. So y dies second in third year. And the answer for example 9 is 0.005175.